Thank you. Am I audible? Hello?
Yeah, you are audible.
Yeah.
Dr. Vikram, you are audible.
Okay.
Go
So,
on.
yeah. Thank you, sir.
Yes.
Okay. So, I would like to thank all the organizer for PMFIC 2021, and especially I would like to thank Dalila Hamish, ma'am, for inviting us from India. And because of this COVID-19 situation, though we are not in person in the Algeria, no doubt Algeria is very beautiful country, and we would like to come and visit to the Bejaia University in near future. But still, we are using this online platform, and we are gathered here over for this PMFCIC 2021 conference. I would like to congratulate all the organizers, and I would like to thank you again for inviting us. Thank you.
Thanks, doctor. Then I think we will start with the presentation of Professor KAITH entitled Designing of Biomaterials Based IPNs and Their Applications in Controlled Release of Agrochemicals.
Good morning and namaskar to everybody. Thank you so much for giving a nice introduction. And before I start with my talk, I must thank Dr. Dalila and her team for inviting me and giving me the opportunity to interact with this August gathering here. My talk, title of my talk is Designing of Biomaterial-Based IPNs and Their Applications in Controlled Release of Agrochemicals. It includes the food scarcity and green revolution. Green revolution, a curse or blessing. Role of biomaterial-based IPNs in evergreen revolution. Eco-friendly behavior of biomaterials-based IPNs. So first of all, I will start with food scarcity and green revolution. You know, hunger remains the #1 cause of death in the world. Other diseases like AIDS, cancer, heart attack, whatsoever it is, it comes afterwards. Globally, you'll find that around 8.9% of the world's population, that's about 690 million people, go to bed on an empty stomach each night. That's the situation all over the world. The number of people affected by hunger has been slowly on the rise. And if it continues like this, it may exceed more than 840 million by 2030. So this is the starvation formula, how we calculate the hunger index. And this is the index strength that can of different countries can be calculated and seen. So the International Food Policy Research Institute provides research-based policy solutions to sustainably reduce poverty and hunger. So before going further, let us see who are hungry in the world. Most of the world's hungry live in developing countries. According to the FAO statistics, you'll find that there are about 1 billion hunger people in the world. About 915 million of them are in developing countries like Asia and the Pacific, Sub-Saharan Africa, Latin America and the Caribbean, Near East and North Africa. So, I will talk a little bit in terms of Indian context also. Say, immediately after independence in India, there was strong need for green revolution. And because of that, a lot of food scarcity was there, and everyone was thinking that there must be a green revolution in the country. And the statement given by the first Prime Minister of India, Mr. Jawaharlal Nehru, he said, everything else can wait, but not the agriculture. You know, agriculture is the most important parameter for any country, for the economy of any country in the world. Further, he said, India cannot be a developed country if it is not developed in agriculture. So agriculture makes the difference in economy of any country, in the GDP of any country. During 1960s, the Green Revolution was brought in India by a team of scientists which were led by Dr. M.S. Swaminathan, this green project, and with the help of Dr. Norman Borlaug from Mexico, who supported the Green Revolution through the introduction of high-yielding variety of wheat seeds. So we always used to salute this father of this Green Revolution, Dr. M.S. Swaminathan, a great scientist, a great scholar. Another hero of that Green Revolution was Padma Bhushan Gurcharan Singh Kalkat. He was another hero of that Green Revolution in our country. And this Green Revolution in our country, it started in 1967, and in 1978-79, we got our goal. Because that Green Revolution, people used various types of agrochemicals in the form of insecticides, pesticides, fungicides, and whatnot. Overdoses were given that time without knowing their side effects, and a lot of production was there. And the Green Revolution resulted in a record grain of output of around 131 million tons in the year 1978-79. And this has established India as one of the world's biggest agriculture producers. So, no doubt we could achieve our goal within a span of about 10 years, between 1967 to 1978. But the question here is, Green Revolution, whether it's a curse or blessing, that's a more important point here. So, Dr. M.S. Swaminathan, he warned the scientists, the agriculturists, the farmers, and horticulturists about the side effects of these insecticides, fungicides, and herbicides and other agrochemicals. In 1968, the vision of that person. He said, indiscriminate use of pesticides, fungicides, and herbicides could cause adverse changes in biological balance, as well as may lead to an increase in the incidence of cancer and other diseases. So the toxic residues present in the grains or other edible parts. It may only lead us to an era of agriculture disaster in the long run. This is what is happening today. This is the era of agriculture disaster this time, rather than to an era of agriculture prosperity. No doubt, our markets, they are flooded with various types of eatables, maybe in the form of fruits, vegetables, food grains, bakery products, and whatnot. Markets are overflooded with various types of eatables. But the problem is the side effects. We are eating the chemical food. We are not getting the organic food now. And every one of us is facing the one or the other health problem. A lot of health problems people are facing all over the world because of this chemical food. This is because of the consequences of this intensive agriculture, overdose of agrochemicals. Our soil has got poison, and the crop yields are very weak and low. Crops become more prone to various types of diseases, and even the marginal farmers, they are committing suicide because of successive failures of the crops. The salinity of the soil has increased, because of which the output of the crops, it has come down. drastically. Another problem is biomagnification through food chains. Again, another health problem. A lot of chemicals, toxic chemicals, they are getting accumulated in our body through the food chain because we are giving excessive doses of agrochemicals to the farms, to the plants. And this biomagnification through food chain is causing a lot of health problems all over the world. Yeah, I can give you a little example here. Say, take the example of ethaphone, and chemically speaking, it is chloroethyl phosphonic acid, and it is used by the farmers and by the fruit growers for giving a good color to the fruits. And if you give a spray at the rate of 2 to 3 ml per liter of water 1 week before harvesting the fruit, you will find a good quality, really fascinating fruits. But the problem is, it's a chemically treated fruit. In the center, you will find the good color fruit. It's a chemically treated fruit, not the original fruit. In the periphery, you will find the original fruit. But market value is that of the chemically treated fruit, because people are not knowing about the side effects of such chemicals which we are spraying to the fruits and to the plants. Even to enhance the shelf life of the vegetables and fruits, we are using calcium chloride solution. 4% of solution used, and you can enhance the shelf life of the vegetables and fruits and other eatables. But again, this is a chemically treated eatable. And even fruit, in case of fruit ripening, we are making use of calcium carbide. And this calcium carbide releases the ethylene. In fact, this ethylene is the a natural aging hormone in the plants. And the ethylene, which is released by calcium carbide, behaves like a natural ethylene hormone, aging hormone. And you can go for quick ripening of the fruits by making use of calcium carbide. Again, we are playing with the lives of the people. We are giving not the fruits to the people, we are giving chemicals to the toxic chemicals to the people. You'll find that use of fungicides, herbicides, insecticides, and other agrochemicals. There's a tremendous use of such chemicals in the form of carbendazim, difenoconazole, zeram, hexaconazole, dodine, and so on, all over the world. This means we are causing a lot of environmental hazards, as well as we are causing the health of the people. Oxytocin, another example, is another hormone. No doubt it occurs naturally, but we are giving injection of oxytocin to the fruits and vegetables just to increase their size overnight. And again, we are causing chemical toxicity to the fruits and vegetables. So this is the table where there is an increase in pesticide use country-wise. People are using extensive use of agrochemicals they are making use of, and this is how you can come to know about from this table. So I will show you why starvation is there. This is because of the overpopulation of some of the countries. You see, some of the countries are like China and India, followed by the US. China and India, they are at the top. If I talk about my country, we don't have much area. We have around 2.4% of the total geographical area of the world. But we are hosting around 18% of the world population. This is really unfortunate, and it's overpopulated. That's why there is no time to relax. We have to shape our agriculture future. It's very important. It's the need of the hour. Population rich but land-hungry countries have no option except to produce more food grains and other agriculture commodities per unit of land. At the same time, you find that there's a lot of biotic and abiotic stresses on the land. We have to think about that too. Such a challenge can be met only by harnessing the best in frontier technologies and blending them with our rich heritage of ecological prudence. Eco-technologies for an evergreen revolution should be the bottom line of our strategy to shape our agriculture future. So, this is the age of evergreen revolution. We have to increase the productivity in agriculture sector, in horticulture sector, and in other sector, without compromising with the ecological system of our country. We have to take care of the ecosystem of the country. The evergreen revolution, it consists of organic agriculture, it includes green agriculture, eco-agriculture, EM agriculture. This EM agriculture is nothing but microorganism based agriculture. We are making use of white fungi and natural farming. Now I've come to the role of biomaterial based IPNs in evergreen revolution. Scientists, particularly the chemists, they can play important role in bringing the evergreen revolution all over the world. Before coming to that, let me give a little introduction about these superabsorbents. These superabsorbents are 3D polymeric networks consisting of hydrophilic cross-linked macromolecules. This 3D network retains large quantities of water or any other fluid without dissolving in it. They have the capacity to take up a very large amount of liquid, aqueous fluid, in comparison to their initial weight. This great affinity for uptake of aqueous fluid is because of the presence of certain types of functional groups like carboxylic acid, OH2, CONH2, SO3, etc. It is because of the presence of such types of groups in the superabsorbents. And these superabsorbents, they are highly sensitive towards pH, temperature, and other parameters. And because of that, they can respond to different types of stimuli. We call them as smart materials also, or smart polymers also. So properties of these superabsorbents, they have got high tensile strength. They are highly biodegradable. They have the capacity for retention of structural integrity. They don't lose the structural integrity even after swelling to a very large extent. And they have got a lot of chemical diversity because of the presence of different types of functional groups. And excellent biocompatibility. They are highly biocompatible. That's why they can be used in used for biomedical purposes. High permeability and viscoelasticity. So I'm giving you the example here, farming without soil. It's a new Japanese technique, growing fruits and vegetables possible in any environment. Here they are making use of such materials, such smart materials, for growing various types of fruits and vegetables. So I'm coming to the work being carried out at NIT Jalandhar by our research group. Our research group is making use of various types of backbones, natural backbones, sligo, commiforamocul, psyllium, gum gati, gum tricon, gum arabica, etc., etc. Our group is making use of natural backbones, which are highly biodegradable and highly biocompatible in nature. So we are taking the natural backbone, and our aim is to synthesize the device which can be used for control release of biofertilizers or control release of urea, potassium nitrate, and other agrochemicals for proper growth of the plants. And there must we should not poison our soil. We should not give overdoses of agrochemical to the soil, because of which the soil is losing the fertility. So these materials can be used as a control devices for the control release of agrochemicals, and our aim is to make the best use of such materials in the controlled release of agrochemicals to the plants without any adverse impact on the natural environment, on the soil. We are preparing these such materials under different reaction conditions, maybe in air, maybe under the impact of microwave radiations and gamma radiations. So question is, what is the need of moisture retention? Why? Why do we need such devices? You know, in the drought-ridden regions and areas with scanty rainfall, there is need to conserve moisture for the growth of the vegetation, because moisture in the soil is required for the proper growth of the plant, for the survival of the plant, for the sustenance of the plants. So these new class of polymers, the smart, which we call as smart materials, has proven to be the boon to the agriculture sector. They can be used in the agriculture sector for the retention of moisture in the soil, and for the which is very important for the proper growth of the plant and for getting better output out of those plants and crops. And we can call them such materials as mini water reservoirs in the soils. These are some of the materials which we have prepared in the lab, and they are after uptake of aqueous fluid. You see yourself, the structural integrity is maintained, and they can swell to a very large extent. They can uptake the aqueous fluid to a very large extent in comparison to their initial weight. And these are some of the materials which our research group could prepare in the laboratory, and they did some of the liquid uptake studies on these materials. And these are another materials which we prepared in the laboratory. So these materials were used for the retention of moisture in different types of soils. In fact, we used 3 types of soils in the laboratory. There's a sandy soil, clay soil, and a mix of 2. And we found that these materials are very effective in the retention of moisture in the soil. That I will show you the table here. 3 types of soils and different types of materials we used for the retention of moisture in the soil. Yeah, see here, it's quite clear from this table. You'll find that first one is the control, where we did not use any sample. A simple soil was there, sandy soil, clay soil, and mix of the 2 soils we have taken. You'll find we have taken our lab samples, which we synthesized in the laboratory, and these samples could retain the moisture in the soil for a longer period. Now, it's quite evident, even up to 60 days they can retain the moisture in the soil. They can be used very effective mini reservoirs for the crops and plants. Another, we did control use of agrochemicals to the plants. These studies were carried out in our laboratory. And before coming to that, need of control use of fertilizer devices. Why do we need? Yeah, please. Hello. After effects of green revolution, because a lot of side effects you must have seen the green revolution has. Everyone is feeling a lot of side effects, health effects are there. High water solubility of fertilizers. Fertilizer, they have got a lot of, if you give a high dose of fertilizers, that is going to dip into the underground water table. Overdoses are going there, and from there they are going to have biomagnification effect. A rising cost of the fertilizers. Economy plays an important role for the farmers. And here you are releasing the fertilizers and agrochemicals in under a controlled rate at optimum dose. And increasing BO and COD levels that you can definitely decrease by use of such materials. And eutrophication and biomagnifications can be reduced here by use of such materials. And sustainable use of fertilizer, that's very important from farmers' point of view, from their economic point of view. So we prepared the biofertilizers from the vermicompost in the laboratory. And we carried out the control use of this biofertilizer through our material which we synthesized in the laboratory. For that, we have taken the black grams for, to carry out our studies. And you will find in the first row, there is a negative control. In the second row, this is a positive control. And third one is the test sample. So you will find that the growth in the test sample is much better as compared in negative control and positive control. Yes, in negative control, you'll find we have not given anything to the plant. No fertilizer was given. In the positive control, we have given fertilizer to the plant, but directly. It was given to the plants directly. And in case of test sample, third row at the bottom, you'll find that we have released. There was a controlled release of fertilizer through our devices, which we synthesized in our laboratory, and we studied the growth of the plants for about 55 days, and we took the photos accordingly at the interval of about 7 days, and you find that the growth in case of the fertilizer released to our devices is better as compared to the direct impact of fertilizer to the plants, or without impact of without giving any fertilizer to the plants. So you can compare yourself the growth in case of test samples, in case of positive control, and in case of negative control. Similarly, you'll find these are all test samples, different devices, samples we synthesized in our lab, we used for the controlled release of fertilizer to the plants. This is the impact of biofertilizers on plant growth. You see yourself, the growth was very good. And now I'm going to the root nodules. You'll find here how root nodules are very important for the, you can say, for symbiotic association and for fixing of nitrogen to the plants. It's very important, root nodules. And you'll find that through controlled release of fertilizers, we could we could get root nodules. You will see here in the root nodules are there. Through controlled release of fertilizer, the roots were in the position to produce nodules, which are very helpful in the fixation of nitrogen in the soil, and nitrogen is required for the vegetative growth of the plant. So that's why we got better vegetative growth because of this, the development of such root nodules through controlled use of fertilizer to the synthesized samples. You will not get any root nodule in case of negative control and positive control. But in case of controlled use of fertilizers, agrochemicals, you find that root nodules are developed. That's the beauty of the work which we carried out in our laboratory. Similarly here, in these samples, we could get root nodules in the roots. So this is the effect of control is of biofertilizer on growth of parameters. Here we took shoot length, root length, fresh plant weight, and dry plant weight. And you'll find that it's better in case of our test samples in comparison to positive control and negative control. We got better shoot length and root length, and better fresh plant weight and better dry plant weight in comparison to positive control and negative control. Similarly, we carried out the release of control release of urea, and we observed its impact on the plant growth. Again, we carried out our negative with the studies with our negative control, positive control, and test samples. And again, we found better growth in case of control release of urea through the device synthesized in the laboratory. Similarly here, these are all test samples. These are all test samples. So effect of control is of urea. You see here, again, we studied the shoot length, root length, fresh plant weight, and dry plant weight in comparison to positive control and negative control, and we found better results in case of the control is of urea through our synthesized samples. And similar studies were carried out on the release of potassium nitrate, another fertilizer which farmers are using, and we got similar type of results. But better results we got in case of biofertilizer in comparison to urea and potassium nitrate. And these are the parameters. Again we found better results with the controlled release of potassium nitrate through the synthesized samples in comparison to positive control and negative control. So further, we study the biodirection behavior of these such materials through soil burial method, composting method, and vermicomposting methods. 3 methods we used, and these studies were and biodirection behavior was studied at the interval of 7 days, 35 days, and 70 days. And you'll find that in case of soil burial method, within 70 and 80 days, within 70 days, the degradation was more than 80%, and almost sample got degraded in the soil. There was no problem with the degradation of the samples. Similarly, in the case of composting method, within 70 days, more than 90, around more than 80% was got degraded in the soil. And similar was the case with our vermicomposting method. And here also in 70 days, more than 70%, more than 60%, it got degraded in the soil within 70 days. So you'll find here, this is how the journey of smart polymers started in agriculture sector. So now the farmers, they are not the simple farmers. They are smart farmers. They are prosper farmers. They know how to get more benefit out of the minimum. And we are using all latest types of technologies in their farms, in their fields, and they are getting better crop yields as compared to the earlier farmers. And our journey with smart polymers continues. And to fulfill the ambition of His Excellency, former President of India, Dr. APJ Abdul Kalam, who was a great scientist, great scholar, and a great technologist. So he is also known as the Missile Man of India, a great technologist, a great scientist. So this is my research group, but this is not complete. I have to add some other students also who are working in my lab, and because of which I am presenting my work in front of you. It's because of this research group, and I'm highly thankful to my research group. They are working very hard. Day and night they are working in the lab. A person who never made a mistake never tried anything new. This is the Albert Einstein who once said. We must keep on doing something new, and we should always have the positive attitude. Keep your face always towards the sunshine, and shadows will fall behind you, definitely. We should always be optimistic in our life. This is our beautiful NIT Jalandhar campus. Thank you. Jai Hind and Jai Bharat.
Thank you, Professor, for your presentation. That was very interesting.
I think it's Valentine.